Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm I am Daniel Azri bin Mat Zaini, matrix number ADY90234 from section 1 from group 11 will present about review on design and modification of air dehumidifier for domestic purpose. Okay. So for introduction, water is very important for mankind as it's been used daily. Research interest regarding the use of condensed water from air conditioning systems has increased for past 15 years. Scientists has been studied mainly in climatic conditions where HVAC systems are widely used for refrigeration. An atmospheric water generator or AWG is a device that extracts water from humid ambient air. Okay, then the extraction of atmospheric water may require a significant input of energy. Some AWG methods are completely passive, relying on natural temperature differences and also requiring no external energy source. And less refrigeration, air conditioning equipment usually reduce the absolute humidity of the air processed by the system. Okay, then we'll continue for literature review. Dehumidifier. Air dehumidifier is a machine used to reduce the relative humidity of a room to make sure that the moist space water molecules are reduced for the comfort of the tenant. The relative humidity RH shows the percentage of moisture in the air, and different room temperature can hold different amount of moisture. Atmospheric water vapor processing technology is reviewed. These processes can extract water molecules from the atmosphere, ultimately causing a phase change from vapor to liquid. Okay, now move on to design and analysis. Okay, this diagram shows the example of air dehumidifier. Okay, so for the design, it utilizes refrigeration principle to make wet cool. It must heat after condensate water is removed. The wet water exchange the heat with evaporator. The water was condensed as below dew point, and less air discharged as the temperature dropped. Okay, now move on to the one of the subtopic inside the design analysis, which is temperature control. If the room temperature is outside the operating range, which is 3 to 35 degrees Celsius, the air humidifier will stop. But if the room temperature is within the operating range, it will restart automatically. It is to ensure room temperature is in ideal condition. Also, it will consistently reducing the RH value. Okay, so we continue. This is the example of air dehumidifier with capillary tube. There are some label. The number 1 is compressor. Number 2 is evaporator. Number 3 is condenser. Number 4A is capillary tube. Number 5, liquid line dryer. Number 6 is solenoid valve. Number 7 is a fan. And number 8 is the receiver. Okay, now we continue with another example of air dehumidifier, which is air dehumidifier with thermostatic expansion valve. This also been labeled number 1 is compressor, number 2 evaporator, number 3 is condenser, 4B is thermostatic expansion valve, number 5 is liquid line dryer, number 6 is solenoid valve, number 7 is fan, and number 8 is receiver. Okay, now I will move on to the next subtopic under design analysis, which is humidity problem. It is categorized into two main classes. The first is excess water content in the air, and the second is excess water content in materials. Okay, so I've prepared a table that shows the different problem with different requirement and different typical location. Okay, so for the first problem, excess water content in the air, the requirement is establish good indoor climate and also preserve and protect goods and materials. This is the requirement. And the typical location is office buildings, domestic properties, conference rooms. For the preserve and protect goods and materials, the typical location is museums and exhibitions, storage rooms for sensitive goods, waterworks, and etc. Okay, then for the second problem, which is excess water content in the materials, the first requirement is dry out buildings. It is usually the typical location is construction site, and for the second in excess water content in materials is the requirement is repair water damage. The typical location is sites affected by floods, fires, or burst pipes. Okay, so in this project, we are more focused to the first one, establish good indoor climate, as it is used in mostly in the room. Okay. Okay, then for discussion, firstly, the purpose of the machine by related the problem of water resources was discussed. If the quality of life is higher, the resource use is often affected by low efficiency and the cost of water is high. In this situation, more sustainable management of water production and distribution is needed. This project will be more or less a teaching tool for future devices. Also, possibly be used. This project will possibly be used to aid communities that lack potable water supply. Okay, this is the example of calculation. The figure above show basic functional principle of condensate drying dehumidifier. So we calculate it as this. This is our group discussion of the calculation, and we calculate it by referring to the thermodynamics table of refrigerant R407C. Okay, there are 4 states, and then we continue the refrigeration effect QL. We get 171.4 kilojoule per kilogram. The heat rejected QH equal H2 minus H3 is equal to 181.5712 kilojoule per kilogram. Okay, the work done by compressor is W is equal to H2 minus H1, and we get 10.1712 kilojoule per kilogram over kilogram. Okay, so cooling effect we get 16.8515, and the heating effect we get 17.8515. Okay, so for the conclusion, in a nutshell, an experimental application of an integrated system is presented in this project. A sustainable approach to this problem would address optimum water production, internal thermal comfort offered by the air conditioning system, and system efficiency dependent on local climate conditions and changes all at the same time. In addition to providing domestic water heating and delivering dry air, dry and fresh airflow, the system can remove water from the air using a reverse compression cycle and treat the water to make it fit for human consumption. Okay, last, from this project, the objective can be achieved by obtaining the appropriate pressure, suitable humidity, suitable type of coolant, sufficient amount of water vapor, and high extraction efficiency. Okay, so that's all from me. Thank you, Dr. Lukman, for listening this full presentation. Okay, so that's all from me. Thank you.